In this next series of videos, we want to look at some different ways to create new functions. We already know that we can use transformations, translations, reflections, rotations, stretches to create new functions. But we can also do that through simple operations, adding, subtracting, multiplying, dividing, and later we'll talk about composition. So today we want to talk about just taking two functions that we know and adding them together to create a new function. Now, algebraically, this is easy enough. So if I wanted to create h of x, which was f of x plus g of x, where I have f and g defined here, then algebraically my new function would be, in this case, a more complex quadratic function. But let's just think a little bit about what's going on numerically and graphically when we do that. So I'm going to take some values of x, and I know for f of x the y values are like so, and for g of x my y values would be like so. And so for h of x, for a given value of x, our new y value is just the sum of our original y values. So our new y value would be 7, sum of these 3, 1, 1, and 3. Okay, so that makes sense. Now if we graph all of these functions on the same grid, then on my new graph I can think of the points that I get as the sum of the y values of the original. So for example, at -2, I'm basically adding y equals 3 and y equals 4 to get y equals 7, which is off my grid. So let's do -1. A y value of 1 plus a y value of 2 will be a y value of 3. At x equals 0, y value of 0 plus a y value of 1 is a y value of 1. And same thing at x equals 1. Our new y value will be 1. So at x equals 2, we have a y value of -1 plus a y value of 4 to be a new y value of 3. And so it looks like maybe our new function is somewhere like that. There's my two functions, and I want my third one to be the sum of the first one plus the second. And so the y values of this graph plus the y values of this graph should give me the y values of the new graph. And it's kind of nice that on the table you can see the three functions and you can see how the y value of the third comes from the y values of the first two. So you can create new functions by adding existing functions. You could also do the same thing with subtracting functions. So let's just change this on my calculator. What does the graph look like when I subtract the y values? Let's just look at the y values on the calculator. Okay, so the new y value is the difference of the original y values. Now it's going to get pretty big here, so if we go backwards, okay, that'll fit on the screen. I'm just going to change this a little bit to 12. See what we've got. Now it's not always easy to visualize the addition or sum of two functions and what the new function might be. Okay, so we again get a parabola. And so let's just take a point here. We're saying that the y values right here, at x equals -1/2 I'm at, the y value here on the blue minus the y value on the red, so that's about 0 on the blue, minus about 1 on the red, would be a negative value, which would be the y value of the new graph. Let's do one more example by hand. This time we're going to subtract two functions. So h of x in this case will be f of x minus g of x, which again algebraically is easy enough. It's just x minus the square root of x plus 1. And so visually, let's just take a couple of points. F of x g of x. Now, when we put negative 2 in, we get a negative value, so there's no value there. In other words, the function is only defined, we know, from x greater than or equal to negative 1. This original function was defined for all reals. And because of this, it makes sense that our new function will only be defined where both functions are defined, and that would be at the overlap of the two domains. So in this case, our new function can only exist when x is greater than or equal to negative 1. So plugging in negative 1, I'm going to get 0 on the square root function, 1, square root 2, square root 3, square root 4, which is 2. And I know what this graph is anyway. It's a basic square root function shifted 1 to the left. And my new function now is the difference of the y values of the original functions. So starting here, subtract them. Now, as I said, I can understand what's happening with the y values in terms of a table. Sometimes it's hard to figure out what the final graph is even after you plot these points. So let's just see what happens here. Negative 1, negative 1, that's my new y value. 0, negative 1, that's this y value. Those two, that's about negative 0.4. So that point would be about there. The next y value is about 0.26. It's about there. And the final one is 3, 1, which is about there. Okay. Well, I can kind of see maybe a pattern going like that. I'm not completely sure. Let's just check out with the calculator what's going on. Got my two functions set up and the difference. And I've got the right idea with my new function. I'm just not sure what's going on between negative 1 and 1. Let's just take a closer look. At negative 1 on my new function, let's go down to y3. We're at negative 1 for y, and as we scroll along, it goes a little lower than that for a bit, not much, back to negative 1, and then it goes up. So it's dipping a bit and then going back up. So combining two functions with addition subtraction can be quite powerful in producing new functions. Here's just a couple of other examples. A basic cosine graph and y equals 2, and I'm going to add them together. You should be able to predict what's going to happen there, I think. Original cosine, basic y equals 2, combine them. The y values add together and push the new graph 2 units up. If I change the second function to not 2 but x, can you imagine what the new function will be when we add these y values together? A climbing wave. And so you can create many more complicated functions by adding, subtracting, and later multiplying and dividing old functions to get new ones. Here are some other examples of the possibilities. Take a sine graph and a cos graph, add them, and get a different kind of wave. An absolute value graph plus a cosine graph produces that. And so when you do this, what you'll notice is that you often get a new function that has some of the features of the old function. It's like two functions getting together to create a new function, and you can see the characteristics of the original parent functions in the new function. Have fun.